Good evening, sir.
Good evening, sir.
Yeah, good evening all. Good evening all. So, which chapter we were doing in the last class?
Sir, combustion and flame, sir.
Okay, so we had done the combustion and flame. Now see, today we'll complete that along with some question answers of that chapter.
Hello, sir. Good evening, sir.
Yeah, hello Venkat.
Sir, I
It was,
am new for
yes.
the class, sir.
Okay, so very good. Welcome Venkat. So first of all, during the class, try to keep your camera on. Okay,
Okay, sir.
enjoy your class. You can eat your chocolates. You can eat your biscuits. You can drink a cold drink. There is no obstruction on that. Okay. But keep on writing, keep on making the notes, be active during the class.
Okay, sir.
Thank you. Okay, so just be active whenever your name is called, answer it and do not run here and there. Whenever you have to leave the class, for example, if there is some urgency and you need to leave the class, so at that time just inform. Okay, inform and then leave. Don't just quit the class, right?
Okay, sir.
Okay. So let's continue with combustion and flame.
Sir,
Yes.
sir, tomorrow is my science exam.
Tomorrow is your science exam. So which all chapters are coming?
Microorganisms, spread and flow, and combustion and flame, force and pressure.
Microorganisms and
Combustion and flame,
Mhm.
force and pressure.
Okay, so I think microorganisms has been completed.
Yes, sir. This is a status. This is in my human statistics.
Okay, just 1 minute. Let me share the screen. And all of you, whenever you require to ask anything, I think most of you know, most of you are active also. So you try to respond during the classes. Okay, so remain active. Try to respond during the classes. So this chapter we are doing combustion and flame. We were discussing the different zones of candle flame. Now, can anyone tell me the temperature of the hottest zone?
The screen is not visible.
Okay.
Sir, outer zone, sir. Outer zone is the hottest one because it is easily combustible.
No,
It
sir.
is
The outer zone of the flame is very hottest zone, and it is more than 100 degrees temperature, and it
Sir,
can
it's
it is
So
the
on a
12
temperature is
1200
1200 to 1400 degrees Celsius, sir.
It's greater than 14, it's between 1200 to 1400 degrees centigrade.
yes, sir.
Okay, so the temperature of the outermost flame is between 1200 to 1400 degrees centigrade. Can anyone tell me what is the color of the outermost flame?
Blue, sir.
blue, sir.
Blue, sir, blue.
So color of the outermost flame is blue. Is that the luminous zone or the non-luminous zone?
Non-luminous zone, sir.
Non-luminous,
Yes,
sir.
yes, blue color is non-luminous. Which part of the flame is the luminous zone?
Sir,
Inside part, sir. Inside part.
The inside orange part,
Inside
sir.
part.
Orange, sir.
Actually, your voice is not heard.
No, not the inside part.
Sir, the
But
orange,
Orange
sir.
part, sir.
the middle zone.
The
Okay.
middle zone.
Middle zone of the flame is the luminous zone. Okay. Then, what is the innermost zone? Can anyone tell me the characteristics of the innermost zone?
Its temperature is low compared to the other layers of the flame, sir.
Its temperature is 800 degrees.
Yes, its temperature is about 800 degrees centigrade. So it's low as compared with the others. Just here I'm showing you the layers of candle flame. Mm, just 1 minute. If I have, yeah, here. These were the different layers of the candle flame which we were discussing. Hottest part, that is the outermost zone, outer zone of complete combustion. So outer zone is the zone of complete combustion because of the availability of sufficient amount of oxygen. See, in actually, we had defined this. We had defined the flame to be. We had defined the flame to be the region where the gases burn. Right? Anyone remember the definition of the flame? The region where the gases burn is the flame. Okay. So actually, this region which we see as the flame.
Sir,
Okay. So here, the different zones that we had seen, eventually this flame that we see, this is actually gases. These are all gases. So which gases are there? The vapors of candle. So actually this is the region. What is contained in this flame? Yes, what is contained in the flame?
The gases burn, sir.
Yes, the gases. Okay. You can say vapors of candle. So vapors of candle, they are present inside this flame. Okay. Now, as these vapors start burning, you observe the flame. Now, to burn them, there should be availability of oxygen. So when oxygen comes and combines with these gases, they start burning. So since everywhere surrounding it is oxygen, so oxygen first comes or it is sufficiently available to the outermost zone of the vapors. Okay, or outermost layer of the vapors when oxygen starts diffusing to it. Okay, so the maximum availability of oxygen is to the outermost layer. Okay, hence in the outermost layer of these gases, it is the hottest zone, and it is also called as the zone of complete combustion. It is also called the outer zone. Got it? And it is blue in color. Then we have seen the middle zone, and the middle zone is also called as the luminous zone. It is about orange in color. So it is the zone which brings light. We observe light because of this zone. Okay. So the middle zone, it is the luminous zone. Got it? And we observe the shape of the flame over here. This is the shape generally which we observe for any flame. Okay. Can anyone tell what will be the shape of the flame if we try to burn this without gravity? Suppose we try to burn it somewhere where there is no gravity,
Sir, it won't
or
burn,
in
sir.
a region of zero gravity. But I'm just
Sir,
telling there is no gravity,
sir,
but
it
there is
won't
oxygen.
burn.
There is oxygen, but there is no gravity.
Same position.
See, when there is no gravity, the flame structure would be somewhat spherical in structure. You will observe spherical flame. Instead of having a flame like this, you will observe a spherical flame when there is no gravity, under zero gravity. So you can also say that the shape of this flame is due to the gravity. So you got a new point now? I
Yes,
think
sir.
all of you knew about this flame, the different zones, but no one knew why the shape of the flame is like this. So now if you get why the shape of the flame is like this? So what is the answer? Pranav?
Sir,
Yeah. Why is the
Bec-
shape of the flame like this?
because there is gravity, sir.
Yeah, because of gravity. And what will be the shape of the flame without gravity?
Spherical, sir.
It will be spherical. Okay. So just we'll try to look for it also. And one more interesting fact I will tell you about the innermost zone of the candle flame. Okay. I'll tell you
Unburnt
one.
carbon particles, sir.
No, not unburnt carbon particles. They're a very interesting fact which I will be telling you from this one. Okay. Just let me show you if I can show you the shape of flame in zero gravity. Okay, let me show the images. See, see, do you observe here a spherical shape of the flame? Something like this, a spherical
Yes, sir.
shapes. Okay, so these are the shapes that will be there when you observe a candle flame with zero gravity. With gravity, this is the structure of the flame. Got it now?
Yes,
Okay.
sir.
Okay, so now another
Yes, sir.
interesting fact. There another interesting fact about this flame I will be telling later on before the end of the class. I will tell you about this. Another thing about this.
Sir, it seems that Lasya is leaving because her speaker is disabled.
Okay, Lasya. Okay, Lasya, I think I got to know your speaker is not working. You can try to connect any headphone. Are you there? If okay, just let me check out.
Sir,
Okay. Okay, anyone, if anyone will, if she talks to anyone, please inform her. She can use any of the headphone or she can use even a mobile also during the class.
is my voice audible now?
Yeah, you are audible.
Yes, sir. Sorry, sir. My speaker was bad, so I just rejoined again.
Okay, no issues. So see, I think we, okay, yes.
Sir, I'm Charan. I actually joined at before 5 minutes only. Can you tell me what was happening?
I think you must go to the video recordings because we can't repeat everything, right? Yeah, we were discussing about the different zones of the candle flame. Okay.
Okay.
Okay, so you can go and see about the different zones of the candle flame and a few interesting things which we came to know. Now, see here, different activities at different types of combustions that can take place. See here, I told you also the blue flame of the gas stove. So when we observe the blue flame of the gas stove, it means that here complete combustion is taking place and whatever amount of energy is being supplied to the gas stove, it is completely converted to heat energy. Okay, very less part of it is getting converted to the very less part is getting converted to light energy. Okay, almost all the part of it is getting converted to heat energy. And on the second hand, you have a candle flame which produces light as well as heat.
Sir,
Yes.
like I have seen in some cinema, like
Mhm.
if we produce flame with carbon, it seems like in yellow color, sir.
See, different substances, they will produce different color of the flames. Different substance. Like if you try to burn sodium, it will produce yellow flame. If you try to burn magnesium, you will
Yellow,
get a
white flame.
white flame. Yeah. So when you burn magnesium, you get a white flame. So different substances will produce different types of flames.
Sir, which produces
Ah,
green
yes.
flame?
Yeah. Just pardon your question.
Ma'am, which substance produces green flame?
Green flame. Okay. I need to. So I think it should be. It should be copper.
Okay, sir.
Okay. But I'm not sure. I will confirm you after checking it out. But it must be copper.
Sir,
Okay.
we burn cracker sticks, sir, while Diwali. That is also separate combustion.
Yeah, see, the burning of the crackers, when we are talking of the crackers, so that is also a combustion reaction.
Like it
For the
produces different colors.
yes, because different substances are over there. There are different substances, so different colors of flames are produced. So
Okay,
the color burning of the crackers, it is very fast combustion. The combustion is very fast. And if combustion is very fast, a lot of heat energy is released, which is uncontrollable. And we call such reactions to be explosive or explosions. So this is highly explosive. Burning of crackers, it is highly explosive because the substances which burn, they burn with a very rapid rate so that the amount of heat energy that is produced cannot be controlled. Okay. So I think everyone is clear about the flame.
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. What will happen if I allow very less amount of oxygen to be supplied to this flame?
Sir, it will stop burning.
It won't burn as the
Mhm.
about the hottest part, sir.
See,
Sir,
everywhere
what is the
okay, suppose to this candle, I am burning it in a region where there is less oxygen.
sir? It won't burn
Stop
effectively,
It
sir.
won't burn as its ignition temperature is low.
No, ignition temperature will be reached. It will
Sir,
start
it won't
burning.
burn so effectively, sir.
But it is relatively less, sir.
Okay, let's see what will happen. Burning a candle in less oxygen. So if you have very less amount of oxygen, so how does the candle burn over there? See, we know that the vapors which are produced, the vapors they require, these vapors, they require some amount of oxygen to be burnt. Okay. So whatever vapors are present over here, sufficient amount of oxygen, if sufficient amount of oxygen is available, they will burn. And if there is not sufficient amount of oxygen, so these vapors, they will try rising up. Okay. And hence they will rise upward. They will move out of the flame without burning. Some of the particles, they will be able to escape the flame without burning. And since the main constituent of this candle is carbon, okay, so you will observe a sooty flame.
Black color type smoke.
Yes, a black smoky flame will be observed over here. So whenever a candle or any substance is burnt with less amount of oxygen, so it produces a sooty flame. Got it? So wherever you see a sooty flame, it means the fuel is not burning efficiently. The fuel is being wasted out. It is not burning efficiently.
Sir, this type of sooty flame we only see when the wax is totally dried. When the wax is totally dried and when we burn that candle, that at that moment only we see, right, sir?
Sir, in fire
Uh,
accidents, sooty flame might come, no, sir.
Okay, we'll discuss about extinguishing of fire. Before extinguishing of fire, let me tell you the important fact that I was about to tell you about the innermost zone. So, in the innermost zone of the candle flame, this is the innermost zone of the candle flame. Okay, with here you have vapors, only vapors. There is no combustion taking place over here, and the temperatures are nearly 800 degrees Celsius approximately. Okay, this region of the flame, it provides the conditions. Now see this region of the flame, it provides the condition where we can have which are similar to formation of diamonds.
So, sir, if we put that under lots of pressure, sir, it will form diamond. Like it's not humanly possible, but generally, yes.
Yes. There, if you try to evolve techniques, so maybe you will be able to produce diamonds over here in this region of the flame. Got it now? These conditions, they are similar to the formation of diamonds, where since for the formation of diamond, you should be having carbon in the vapor state, and you should have the temperatures to be about 800 degrees centigrade. Okay, so these are the conditions which are met over here in this region of the candle. Got it, everyone? If sufficient amount of pressure happens, so maybe, or if you have a very big flame of that sort, is an intense pressure and it may lead to conversion of diamonds also. Got it? Okay, so any other doubt? Now we shall move ahead with fire
Yes, sir.
extinguishing. So our next topic is fire extinguishing. How can extinguish fire?
By fire extinguishers, sir.
Okay, so we are doing
Sure,
firefighting.
by keeping sand and what
Sir, water also we can keep, no, sir.
So
Water.
what all things? See, you must need to think of, are all fires same
No, sir.
everywhere?
No, sir.
No, sir.
Fire, gas fire, and solid fire. No, electrical fire is also.
Okay, see, not only electrical, even if you have some fires due to petrol or other things. Okay, so what is the difference in that? Can we use the same substance everywhere? The answer is no. Okay, so here in the case of firefighting, yes,
Sir, like when the gas is burned, when the cylinder is blast, then we use separate type of chemical to let the fire stop, to let the burning fire off. And if the fuel is burnt, we use another type of chemical.
okay, first of all, we will look what are the methods of extinguishing fire. What are the different methods that we can use to extinguish fire? Okay. So under the different methods, your very first method is lowering the temperature of fuel.
Like we should lower the ignition temperature, no, sir.
Yeah, so that it will not be able to reach the ignition temperature. So lowering the temperature of fuel is one of the methods.
We should cut
And-
off the contact
Oxygen
of
level.
oxygen, sir.
Okay, cut the supply of oxygen. The second method.
Third is we should.
Sir, can we destroy the fuel there?
Okay, how will you destroy the fuel?
Like if we destroy the fuel,
Destroy how? By burning it?
no, sir.
We pour
Then-
sand by adding the sand on it.
So if you add the sand, will the fuel get destroyed? No.
Like sir, not much, but little.
Okay, see. So these methods which we use, lowering of the temperature of fuel, cut the supply of oxygen, and the third method is removal of fuel. Okay. You remove the fuel. For example, suppose if you have a lot of wood which is burning, so you remove the remaining part of the wood. You let the small amount of wood keep on burning, and you can remove the remaining amount of wood, so that if you remove the fuel, then also the fire will go off. Okay, so
Sir?
these are, yes,
We can means even cool it down, right, sir?
what can we do?
Cool, sir. Cool it down.
Cool it down. So that is what we are doing, lowering the temperature.
Oh,
Okay, so for lowering the temperature, we generally use water, as water is available everywhere. Okay, so we use water for lowering the temperature of fuel. To cut the supply of oxygen, there are different methods.
Sir,
like
we can keep a blanket, no, sir, like to cut off.
yes,
The,
use of blanket.
or use fire extinguisher, no, sir. It will cover it. It will use carbon dioxide to cover the oxygen like a blanket, no, sir.
Yes, either you will be using use of fire extinguisher. So either we can use fire extinguisher, or we can use a blanket, or we can also use sand. Sand also performs the same way. When we put sand on a fuel, it cuts off the supply of oxygen. Okay, so these three: use of blanket, use of fire extinguisher, use of sand. Okay, these are the methods to cut the supply of oxygen. Then the last one is removal of fuel. Okay, so here we remove the remaining fuel from burning, or remove some part of fuel and allow only a limited amount of fuel to burn.
Sir, what if the fuel was in a liquid state, no, sir, like LPG, sir?
Okay, yes. So see, all the methods cannot be used everywhere. Like we can't use water everywhere. In the same way, we can't use blanket everywhere. Okay, we can't use the same types of extinguishers everywhere, and we also can't use the third method everywhere, depending on the type of fire, depending on how the
Type of
fire has
combustion.
caught.
So we can say,
Yes.
depending upon the type of the combustion.
Yes. So when you do, when you're doing the different types of fires, so we observe that there are fires which can be due to electricity. So there can be electrical fires.
Sir, for electrical fires, we don't use water, no, sir. Here, water
Yes.
cannot be worked because it can be damaged.
You can get a shock if you are using on electrical fires. If you try to use water, so you may get a shock.
Sir, can I tell the reason behind that, sir? Can I tell?
Yes.
Because all the water around us is almost salt water, sir. It has minimum salt and minerals, so it will pass the electricity through the water and we will get shock, sir.
Yes.
Like
Water will
almost
become
everything.
conducting. Yes, whatever water we have is conducting. So if that water is poured on it, it becomes conducting. It conducts the electricity which is over there. It conducts it, okay? And hence we can get a shock. The next one
Yes.
is oil fires or gas fires. They are very dangerous. If you have oil fires, so in the case of oil fires, can you use water?
Yes, sir.
Yes, sir. Yes.
No, sir. The
Sir,
water
I
will
have
be
a
sink
doubt.
to the
No,
bottom.
I can't use water in case of oil fire.
Sir,
See,
I have a
if you
doubt,
have
sir.
some,
So we
yes,
use a blanket.
okay, see, in the case of oil fires, you can use
Sir,
sand.
doubt, sir.
Yes,
So when these electrical fires or oil fires, it leads to explosion, sir. Is
just
it
pardon.
leads when these type of oil fires or electrical fires are being causing those leads to explosion?
Yes. Yes.
Okay, sir.
Yes, they are causing a number of explosions over there. So whenever you have oil fires or if you have electrical fires, try to control them as soon as possible. Otherwise, they are highly explosive. Oil fires
Highly
generally,
inflammable.
yeah, they are highly inflammable and they are highly explosive. Okay,
Sir,
so whatever, yes,
I heard this fact somewhere, sir. Like I heard about superconductors. If they are cooled at certain temperatures, like the lowest temperature, it can conduct full electricity without wasting any fuel, sir. Like without
yes,
wasting any. Yes, sir.
yes, you are correct. Okay, you are correct about that, about the superconductors. Okay. So superconductor are the substances which can conduct electricity without any resistance, and it happens at low temperatures.
Can you say like that how it can be done, sir?
See, that is a different part. That is when you study about electricity. Okay. So over there you will get to know why there is resistance, why there is wastage of energy, and how can superconductors reduce that wastage. And
Yes, sir.
it is related with the molecular motions.
Yes, sir.
Okay. So now I think you can get to that. We are discussing about the oil fires. So see, if you have somewhere oil fires, you can't use water. If you try to use water, water is denser than oil. Water will go down and oil will again come on the top and hence come in contact with oxygen and therefore still continue to burn. So water is ineffective with electrical fires and oil fires. With the oil fires and electrical fires, you can use fire extinguishers, you can use sand. Okay. Then if suppose someone is burning, so to prevent that person, you can cover that person in a blanket. If you cover that person in a blanket, the supply of oxygen will be cut off and the person will be safe.
Sir, or even when the person caught a fire, we can even make the person to roll on the ground.
What can he do?
We can make the person to roll on the ground, sir, so that
Yeah, he can be made to roll down so that the supply of oxygen will be cut off, and slowly it's just like pouring the sand on his body. Okay, so the supply of oxygen will be cut off, and hence he will be safe. So firefighting, this is what we were doing, firefighting. Yeah, fire extinguishers. Another thing about the fire extinguishers, there are different types of fire extinguishers, like there are gas based fire extinguishers or there are soda acid fire extinguishers. So soda acid fire extinguishers are the extinguishers which include, I'll tell you the name of the chemical. So here, soda acid fire extinguishers, this is an extra thing apart from your syllabus that I'm telling you. They are called soda acid fire extinguishers. So soda acid fire extinguishers, they contain a chemical which we call sodium hydrogen carbonate.
How, like carbonate means CO3, sir?
Yes,
How?
sodium hydrogen carbonate. This is a chemical name. Sodium
NaH,
hydrogen. Yes.
NaHCO3, sir?
Yeah, it is NaHCO3. This is the chemical formula. This is the chemical name. Sodium hydrogen carbonate. And its common name. Can anyone tell its common name?
Sodium bicarbonate, sir.
sodium bicarbonate.
Okay, sodium bicarbonate or its common name is baking soda. This is
Baking
also
soda.
called as baking soda. Okay, so soda acid fire extinguishers, they use baking soda or sodium hydrogen carbonate as a constituent of the fire extinguisher system. Apart from it, they also use some acid, and the acid may be sulfuric acid like H2SO4 or it may be HCl. Any of the acid can be used. A reaction between these two produces carbon dioxide. Okay. And this carbon dioxide, when it is allowed to flow over the fuel, so due to the heat, the carbon dioxide gas over there expands and it cuts off the supply of oxygen. Got it?
So the mixture of these gases can expand the level of carbon dioxide there, sir?
Sir, the mixture of these gases will form carbon dioxide, which covers the flame like a blanket, sir.
Yes, the mixture of these two gases will will produce carbon dioxide. And when this carbon dioxide is blown over fire, so it will extinguish the fire.
Understood, sir.
So, okay, I think this method of firefighting, all of you know, where we use water pipes.
Yes, sir.
Sir,
So
yes.
water pipes are
And use
used.
it in a very high pressure, no, sir?
Yeah, they contain a very high pressure, so that the water can be thrown to large distances.
And it would not waste water, no, sir.
Yes. Okay, can anyone tell the reason why there are mostly fires, forest fires in summer?
Amazon forest.
Yeah, why there are forest fires?
Because of dry leaves, sir.
Because
The
of
dry leaves rub each other, then the fire ignites them.
Because means
Sir,
what rub?
because of those
there
dry
is so
leaves,
much
sir.
of heat, sir.
Yes, what rubs with each other?
The leaves, sir.
Dry
And
leaves, sir.
Yes,
The dry
yes, the
leaves,
branches
sir.
of
When the
the
dry
branches
leaves
of the tree.
attach to each other, they cause fire. So it
Yes,
leads to
yes, very good. So the branches of the tree, they get rubbed with each other, raising the temperature of the wood and hence catching fire. Okay. Okay. So bye all of you. See you again in next class.
Thank you,
Sir,
sir.
sir,
Okay, bye.
sir.
Yes.
Like why a heap of pure green leaves cannot burnt easily when
Because
compared to the.
it has
Sir,
water
can I tell
content.
the reason, sir?
It has water content.
sir.
Okay, we'll see
Oh,
in the
okay.
next class.
Okay.
Sir,
We
I have a
don't
doubt,
have.
sir.
I have another class. The students must be waiting
Sir,
right
there
now.
is no worksheet, sir, for the chemistry and physics like biology.
For biology. Okay, I'll send
No,
it.
sir,
I'll
like
send it.
chemistry and physics, sir. Like today, Manisha ma'am have sent a worksheet for biology.
Okay, I'll
So
try.
I can
I'll
prepare
try
for
for
that.
chemistry and physics.
Sir,
Okay.
one more question, sir. The science
Yes.
test is there, sir. Is it for biology or physics or chemistry, sir?
Didn't you get the syllabus of that?
No, sir.
Biology.
I did
Okay,
not
I'll
see,
take.
sir.
Bio,
Okay.
it's actually bio.
Okay, just check the group if there is a message regarding the syllabus. If not, talk to Manisha ma'am. Okay.
Okay, sir.
Yes, sir.
Okay.
Thank you, sir.